There's one command in Unix-based systems that has become legendary for all the wrong reasons. It's short, it's simple, and it has destroyed more data than almost any other single line ever typed into a terminal. That command is rmrf. If you truly understand what it does, you'll understand both the raw power and the raw danger of the Unix philosophy. To appreciate why this command is so destructive, we need to break it down carefully, piece by piece, and understand not just what it does, but why it exists in the first place. Let's start with the foundation. The command rm stands for remove. In Unix and Unix-like systems built around the Linux kernel, rm is used to delete files and directories. Unlike graphical operating systems that move deleted files into a recycle bin or trash folder, rm permanently removes files immediately. There's no built-in undo. Once the file system releases that data block for reuse, recovery becomes extremely difficult without specialized tools. By itself, rm will delete individual files, but it will not delete directories unless instructed to do so. That's where the R flag comes in. The R stands for recursive. Recursion means that the command doesn't just delete a single directory. It enters that directory, deletes everything inside it, then deletes the directory itself. If those contents include other directories, it descends into those as well, deleting everything in a cascading chain. It walks the entire directory tree. Then comes F. The F stands for force. This flag suppresses warnings and confirmation prompts. If a file is write protected, rm might normally ask for confirmation. With F, it will not ask. It will proceed without hesitation. It also ignores non-existent files and keeps going even if errors occur. Finally, there is the slash. In Unix-based systems, the / represents the root directory. This is the top-level directory of the entire file system. Every file, every system binary, every configuration file, every user's home directory, everything exists somewhere beneath. So when you type rmrf, you are instructing the system to recursively and forcefully delete everything starting from the root directory downward. In plain terms, you are telling your operating system to erase itself. Now, it's important to understand what actually happens when this command runs. rm works by removing directory entries and reducing link counts for files. When the link count drops to 0 and no process is holding the file open, the system frees the storage space. With recursion enabled, the command traverses the entire file system tree depth first. It enters directories, deletes files, removes subdirectories, and keeps going until there's nothing left under the specified path. Because the path that means everything. As this process runs, the system begins to destabilize. Core binaries in directories like perbin and /usr/bin start disappearing. Shared libraries in perlib vanish. Configuration files in etc. are removed. Device nodes in dev may be deleted. Eventually, running processes begin to fail as they attempt to access files that no longer exist. The system might continue running briefly because programs already loaded into memory can still execute, but once they require additional files or spawn new processes, errors cascade rapidly. If executed with administrative privileges, the damage can be total. This leads to an obvious question. Why does such a command exist at all? The answer lies in Unix design philosophy. Unix systems were built around the principle that the user, especially the administrator, should have full control. There is no artificial restriction preventing you from deleting critical files if you have the authority to do so. The system assumes that if you are operating with elevated privileges, you know what you are doing. Administrators need powerful tools. Sometimes they need to remove entire directory trees quickly. They might need to wipe temporary files, remove crude environments, or clean up containerized environments. The same mechanism that can destroy a system is also the mechanism that allows efficient management. Unix treats everything as a file. Even the root directory is just another directory entry in the file system hierarchy. From the system's perspective, There's no mystical boundary that makes untouchable. It is simply the top of the tree. That philosophical consistency is elegant, but it can be unforgiving. Over the years, this command has caused real-world damage. It isn't just a theoretical hazard discussed in forums. There have been major incidents tied to mistaken executions of RM commands. One of the most famous stories involves the near loss of Toy Story 2 during production. A mistaken deletion command reportedly wiped out large portions of the film's files. Backups were faulty, and for a moment, it appeared that years of work might be gone. Only through an offsite copy was the data ultimately recovered. While the exact details have been debated, the story remains a powerful reminder of how catastrophic data loss can be. There's another more technical consequence that was discovered years ago on certain older systems. Some early UEFI firmware implementations exposed critical firmware variables through the file system interface. On those systems, deleting specific EFI variable files could potentially corrupt firmware settings. In extreme cases, this could render a motherboard unbootable. In other words, running a recursive deletion that touched those firmware variable paths could permanently brick hardware. Modern systems have since implemented protections, but the incident illustrates how deep file system operations can reach. As Linux distributions matured, developers recognized that accidents were happening. People were copying and pasting commands without understanding them. New users were being tricked into running destructive commands as jokes. So safeguards were introduced. Modern implementations of RM often refuse to operate recursively on the root directory by default. If you attempt to run rmrf, you may see an error stating that it is dangerous to operate on. To override this protection, you would need to explicitly specify an additional flag, typically --no-preserve-root. That extra requirement serves as a deliberate speed bump. It forces the user to be more intentional. Additionally, modern Linux systems have improved protections around UEFI variables. Most firmware variable files are now immutable, meaning they cannot be deleted even by a recursive RM command without explicitly removing immutability flags. This significantly reduces the risk of firmware-level damage. However, even with these protections, the danger is not completely eliminated. There is a variation that bypasses the root directory safeguard, rmrf*. This command does not explicitly target. Instead, it targets everything in the current directory. If you happen to be in the root directory when you execute rmrf*, the result is nearly identical to rmrf. The protection that blocks direct targeting of does not necessarily block deletion of all its contents through a wildcard expansion. That subtle difference highlights why understanding context is critical. The shell expands * before RM even sees it. So the command becomes a list of everything inside the current directory. If that directory is, you are effectively deleting the entire file system again. This is why knowledge matters more than fear. It's not enough to know that rmrf is dangerous. You must understand how globbing works, how shell expansion works, and how permissions function. Let's talk about prevention. The first and most important rule is never run a command you don't understand. If you see something online, break it down. Look up each flag. Ask yourself what the target path is. Ask yourself what directory you are currently in. Use the powdd command to confirm your location before executing destructive operations. The second rule is minimize administrative privileges. Don't operate as root unless necessary. Use sudo carefully. The extra password prompt can serve as a moment of reflection before executing something risky. The third rule is implement protective tools. Some users create aliases, such as alias rm equals or mi, which forces interactive confirmation for each deletion. Others use tools like safe-rm, which block deletion of critical system paths. There are also utilities that redirect deletions to a trash directory instead of permanently removing files. The fourth rule is follow the 3-2-1 backup principle. Maintain 3 copies of your data. Store them on two different types of media. Keep at least one copy off-site. This strategy protects against hardware failure, accidental deletion, and disasters. Without backups, RMRF mistakes become catastrophic. With backups, they become inconvenient but recoverable. Modern file systems also provide snapshot capabilities. On systems using snapshot-capable file systems, you can create restore points before major changes. If something goes wrong, you can roll back to a previous state. Ultimately, RMRF is not evil, it is powerful. It does exactly what it is designed to do. It reflects a design philosophy that prioritizes user authority over enforced safety. Computers do not interpret intent. They execute instructions precisely. If you instruct a system to delete everything under the root directory, it will attempt to do exactly that. The true danger lies not in the command itself, but in ignorance, haste, and lack of preparation. Understanding RMRF is a rite of passage for many Linux users. It teaches respect for the command line. It teaches careful thinking. It teaches the importance of backups. And it demonstrates how small syntactic elements, a dash, a flag, a slash, can combine into something enormously powerful. In the end, the lesson is simple but profound. With great power comes great responsibility. Unix gives you extraordinary control over your system. It does not wrap that power in excessive guardrails. It trusts you. And that trust is both the system's greatest strength and its greatest risk.